3.7 is called graphing linear equations. Inequalities, which is an unequal. So there's, instead of an equal sign, now we're dealing with the unequal sign, or the inequalities that look like this. So instead of it seeing an equal sign right there, you just see a greater than or less than. But to graph the line, it's the same. But then what you're going to say is everything greater than the line or less than the line. So we still want to graph the line, and I like this way to graph the best. If you like x and y intercepts, use that. If you like random points, you can do that. But I'm going to use slope-intercept form. So I'm going to go ahead and solve for y. So I'm going to subtract x from both sides, and then I'm going to divide by 3. So I get this. Now, I graph it just the same as I graph any other regular line. So I know this is my y-intercept, and 4/3 is the same as 1 and 1/3, isn't it? So I would just be right here above 1 a little bit. That's where it crosses the y-axis. Then my slope tells me I go down 1, right 3. So I go down 1, and then I go right 3. So I'm just a third. I'm right above the axis, aren't I? Now, in this particular problem, it says that y is greater than the line. It doesn't even say it's equal to the line. If it said greater than or equal to, I could draw my line. But because this says it's only greater than the line, I have to tell them that it comes as close to the line as possible without actually touching it. So the way we notate that is with a dotted line. And then, if it says y is greater than the line, it's probably going to be above it. But if you're ever not sure, you can check it by just testing a random point. And the easiest point to pick is that 0, 0 right there, the origin, isn't it? So in other words, if I plug 0 in for y and 0 in for x, I would get 0 is greater than 4/3, wouldn't I? And we know that that is not true. That is false, which tells me that this point is not shaded. So we were right. This side is shaded. And so once you have your final solution, you can just kind of shade that lightly so you know on a multiple choice test which graph to pick. And that's your answer. You have just graphed x plus 3y is greater than 4 right there. Alright, now what they can do is they can give you something like this, where they say x is less than 2, and they give you 2 lines. Y is greater than or equal to x plus 1. So this is called a compound inequality because they're both unequal, and there's 2 of them, but we graph them on the same xy plane. So if I see x equals something, and there's only one variable, I know I have a vertical or horizontal line. And if it's x equals, it's going to cross the x-axis at 2. But this doesn't say or equal to, it just says less than. So I have to draw that vertical line dotted, telling them that it comes as close to the line as it can, try to draw it straight, but doesn't include the line itself. And vertical and horizontal lines are pretty obvious. If it says it's less than 2, you're definitely going to shade this side. Now I'm just going to make a notation so I remember which side, because my answer, because it has to be this and this, is only the overlap. You might remember that from earlier when we did compound inequalities. But if the word is and, your answer is what they have in common. So it's where they overlap. So let's graph this one now. This one we know crosses the y-axis at 1. So there's a point on my line right at 1. And my slope is in front of that x is a 1 over a 1. So I'm going to go up 1 over 1. And you could keep doing that. Up 1 over 1. Now this one says it's greater than or equal to the line. So this one includes the line itself. So I can draw a solid line. Now, if it says that y is greater than the line, I would guess it's up here. But let's again just make sure. Let's plug in 0, 0 to verify. And you can always use 0, 0 unless it might be on the line. Then you have to pick a different point. But if I plug 0 in for y and 0 in for x, I get 0 is greater than 1, greater than or equal to 1. And that is not true. So this is not shaded. So we were correct in assuming it was this side. Now look at your arrows and see if you can see where they overlap. This line keeps going right here, and so right here they don't overlap. They just overlap right here. And so that is the solution to that equation. Now that's different than if they tell you or. So let's try an or. If they say that x plus 2y is less than or equal to 4, or y is greater than or equal to negative 1. Now if the word is or, you're going to find the union, or you're going to shade both areas. There's an O in there. So, and is the overlap, or is both areas, the union of the two. So, before I try to graph this, let's go ahead and solve for y. So I'm going to subtract x, and then I'm going to divide by 2. So I have 1/2 x, and 4 divided by 2 is 2. So I have this line and this line to graph on the same xy axis, the same Cartesian plane. So this one crosses the y-axis at 2, 1, 2, and it has a slope of up 1. Oops, did I leave my negative out? I did, didn't I? Ooh, good thing I saw that. We don't want to graph the wrong graph. So we had a negative x, so we have negative 1/2 x. So from my y-intercept, I need to go down 1, right 2. And look at it and decide, is it dotted or solid? And it says less than or equal to, so it will be solid. And your gut will probably tell you the right way. If it's less than, would you guess it would be underneath? I would, but let's verify it. Let's plug in 0, 0 and make sure. So 0 here and 0 here gives me this. And that one's true. 0 is less than or equal to 2. So since it's true, that point is shaded. So we know we're going to shade that side of that line. Now, good review here. Y is greater than or equal to 1. Pretend it's an equal sign. If it were y equals negative 1, you would know this is vertical or horizontal because there's only x or y. And since it's y equals, it will cross the y-axis at the point, at the number. So at negative 1, we cross the y-axis. And look at it and decide, is it dotted or solid? And let me forewarn you, on the test, they'll have multiple choice with both choices. So you have to remember to do the dotted or the solid correctly. Dotted if it's not equal to, solid if it is equal to. So I have a solid line right there. And then this is saying y is greater than or equal to 1. So we know greater than is above. And again, if you want to test 0, 0, you can plug a 0 in for y, and there's nowhere to plug the x in, but that's okay, because I look at it and say 0 is greater than or equal to negative 1, and that's true. 0 is greater than a negative, so I know that I'm shading this side of that line. So if it's or, I'm going to shade both here where they overlap, and also all of this. And also all of this. So if you were going to pick this, you would see this little triangle right here that would be open. And everything else would be shaded because it's or. Now if it had been and, only this little triangle in here would be the answer. But because it's or, they're both shaded. And this is the only thing left out. Okay? So work hard on 3.7. Good luck.